Hello, everyone. Welcome to today's live webcast. My name is Rod Walton, and I'm Content Director for Clarion Events in charge of Power Engineering and Power Gen International. I'll be introducing your panel for today's webcast, which is entitled Grid Disrupted: How Optical Sensing Manages the Chaos with More Accurate Digital Measurements. And it is sponsored by Makatu, Measuring the Future. The goal is building a smarter, safe, and more resilient grid that is ready for renewables, and it starts and ends with real-time data from more places on the distribution system. Before we begin with our speakers, let me very briefly go through some quick tips on getting the most of your attendance on this session. It is recommended that you close down all other applications for better performance. The presentation is both live and interactive, so you can ask questions at any time by typing in the Ask a Question box in the presentation window on the right side of your screen. If you have any technical difficulties, please alert us through the Ask a Question box. A member of our support team will work with you to correct the issue. Okay, that's enough of the housekeeping, so let's get started with the webcast. We have a great lineup today. The session will be moderated by Amanda Frike, who is Vice President, North American Sales for Makatu. Amanda has spent more than a decade working with and for utilities. She comes from a family line of engineers and handles the sales side of engineering for the company. She will moderate the discussion with Michael Oshetsky, who is President and CEO of Makatu, and Kristen Barbado, who is founder and CEO of Build Edison. Michael Oshetsky's career passion is to fundamentally change the way the world senses with light, creating solutions that transform operational awareness. He's guided Makatu in securing millions in investments, state and federal grants since he founded the company 10 years ago. He'll be joined by Kristen Barbado, who is founder and CEO of Build Edison, which provides advisory services, demonstration project implementation partners, go-to-market planning strategies, and a unique investment vehicle for clean techs, facility owners, and energy investors. Build Edison advises entities such as NYSERDA, otherwise known as the New York Energy Research and Development Authority, Murata, and Generate Capital. And with that, I'll turn it over to our moderator, Amanda Frike. Amanda, it's all yours.
Awesome. Thank you so much, Rod. So like you mentioned, we do have that question chat open for you. So we recommend if you have any questions throughout the presentation, we'll have Q&A at the end, but get those questions in. I know Michael and Kristen are both here ready and willing to tackle any of the topics of the day. So with that, I will actually be transitioning over to Kristen to lead us through this amazing presentation. Take it away, Kristen.
Thank you so much, Amanda. Michael, so nice to be here with you today and everybody else on the webinar as well. So excited to talk about this because we have some problems we need to fix on the grid, and there's some really great things that we can do about it. I am excited to hear more about what Michael's going to talk about from Makatu, but before we do that, I'm going to set the stage a little bit about what the outlook is and why we're looking at these types of solutions to begin with. And just as a little run through the agenda here, we're going to talk about what our shared responsibility is toward a greener, safer, reliable grid for tomorrow, today and tomorrow, how we're going to manage grid disruption, what kinds of disruptive technologies there have been, and why data will be the new currency. And then in real life, we're going to look at some utility cases, of course, and how utilities in the Northeast are managing grid chaos, which is something that Makatu knows quite a lot about, since that's what they manage. So next slide. And here we are for grid disrupted. So we're going to think about this in terms of our shared responsibility. Just a note, as I'm sure many of you who are on the webinar right now are paying attention to what's happening in the news in the US, especially in Texas. It's been a very, very interesting time from an energy perspective, to say nothing of the hardships that people are suffering through right now in that area. But what this is reflecting from a grid perspective, I believe, is that there really is a need for an understanding of how these new types of resources interplay with grid and what that means for us in terms of preparedness in some of these types of cases. So as we look to our shared responsibility for a greener, cleaner planet, what does that mean for our grid? So first, let's look at what this means from a renewable standpoint in Europe, and what they've been able to do with increased renewable resources on their grid. So as you can see from the right-hand side, they do have quite some increases in their their renewable numbers, percentages. They have reduced their greenhouse gas emissions by a whopping 24%. They also use about 21% of renewable energy, and they've reduced consumption from an energy efficiency standpoint by about 17% over time. Just a note as we look into some of the other slides, if you're not familiar with what RPS stands for, the Renewable Portfolio Standard, it is a metric by which policymakers have established what percentage of electric utility resources must be sold through renewable resources themselves. So next slide. So now that we're getting a greener resource mix for a cleaner planet, what does this mean in terms of states here, the status of here in the US? Well, as you can tell from that Renewable Portfolio Standard, the RPS, there are several states that have adopted it. On the left, you can see a graphic that has some nice green states that are listed where they have their own renewable portfolio standards, as well as some other great statistics. For example, in the US, $64 billion in the market for wind, solar, and other renewable energy sources, which is a market increase over the years. 30 states, as I was mentioning, plus DC and 3 territories have adopted renewable targets. 7 states and 1 territory have set renewable energy goals aside from those targets, and half the renewable generation growth since 2000 over the last 21 years can be attributed to state energy requirements and those RPSs. Next slide. So now that we've got a greener, cleaner grid, how do we make it a safer grid? Well, renewables and fire hazards do create more challenges, and we have to address them safely. Just as a little primer, I'm sure many of you know, but for the way that the grid was originally designed was a unidirectional flow of electrons from the remote plant to the customers themselves. But now that we have renewable resources and other types of distributed energy resources, DERs, all over the system in the grid, especially within the distribution system, you do have bidirectional or two-way flow or multi-directional flow. This can create, like in renewables, can create backfeed, surges, over voltage situations that, if they're not properly monitored, can be dangerous. So this open bidirectional circuits and the new distributed nature of grid creates hazardous conditions that we need to keep crews safe as well, not just our customers, but the crews that are out there working, trying to keep all the power restored. Sparking, saturation, violent failures, they can create wildfire risk, and also this is another, we need a non-conductive technology that is immune to starting fires in order to address how to sense what's happening on the grid at different locations in a safe manner. So next slide. And that's really where Mikatu comes in. So as a last look at what's been going on in this past 10 years, we have seen, just as described, more storms, drier weather conditions, and more fires that are happening. So weather-related outages are increasing, and we have seen in the US and abroad more acres being burned. So we need to think about the grid and its management in a way that is much more safe and reliable with this bidirectional flow that we keep increasing with renewables and others. So with that as the last thought in this little part of the section, I wanted to introduce a couple of questions for the audience. So for those of you out there, we'd like to understand, and we will present the results of this, how far along is your utility in integrating renewables into your grid? And if you don't work for the utility, you're taking a guess, take your best guesses. 1 is not planning to integrate. 2, planning to integrate within the next 3 years. Another is planning to integrate within the next 5 years, in the process of doing this integration of renewables, and have been integrating within the last year. So Amanda, I'll leave it to you to manage how these poll results come in. But Michael, what are you seeing in terms of integrating renewables from the utility side? Are you seeing an increase?
Yeah, Kristen, we're really seeing a move towards the integration of renewables. And if you really think about it, you hit on some great topics here. As the grid is fundamentally changing from a linear power distribution system to a more circular, right? Our houses, our homes, our businesses now are bidirectional energy consumption. So it's definitely something that needs to be addressed. And I think a lot of our customers and partners are really looking to see how can we optimize this integration and how can we actually have situational awareness.
It's a great point. It's a really great point. And I think that utilities are increasingly looking at this, but the understanding of how and by what means are the utilities looking at the renewables as resources, but also I'm sure they're looking at how, if they're integrating the renewables, what does that mean for the grid and their customers themselves, and at what locations are those renewables actually being located within the grid itself.
Exactly, and it's not a singular point. It's multiple points along from the distribution all the way to the consumption side. So I'm really excited to see what the results are here. So
Yeah, me too.
yeah.
Okay, they're coming in. I feel like we're on How to Be a Millionaire, and we've asked the audience, right?
Nice. What case is it, Amanda?
Right? Yeah, let's get up to the multi-million-dollar one. Let's see. There's okay, we're waiting for it. They're coming. So we've got 32 folks said that in the last year they've started integrating. 29 are currently in process, and 13% are not planning on integrating. That is fascinating to me, that 13% is not planning.
I need to dig into that a little bit more to understand what it is, or maybe they already have, or they're in a state where it's what type of utility they are isn't actually part of the actual ownership, or maybe they're not thinking about it in terms of the grid itself. But for the most part, I think that as the results show, a lot of people are expecting that utilities are trying to integrate renewables into their grid infrastructure, if not by ownership, by at least the impact of what those renewables mean.
Yeah,
So
it's really interesting financially.
Yeah. Well, thanks everybody for those results. We've got one more for you, so keep your fingers ready for the next one. Next question. Since the COVID-19 pandemic began, have you noticed either a load shift or an increased reliance on renewables? So the options for your poll are: our reliance has decreased significantly, it has somewhat decreased, not really changed, somewhat increased, or has increased significantly. So please, again, take a moment to address the question that we have here for the results for the poll. And I'm going to actually weigh in here and say that for where I've seen things happen in my region, which is the New York, New Jersey region here, we have seen some shifts in load. And I think it's because of the way the operations of how people are working and living now. You see a decrease in this region in commercial load. So where people are not going to big office buildings as much, that load has decreased, but it has also probably shifted to more residential or other areas. Where that actually plays into renewables, I'm not quite sure. And so Michael, do you have any thoughts about how any load shift has had an increased reliance upon renewables itself?
Yeah, you brought up a great point, is that since COVID-19 we've been working in a remote world, right? And the load is actually, the dynamics of it is actually shifted. And it's shifted towards the fact is that we still have our factories, we still have the heavy users in manufacturing, but however, the office loads have really shifted around. So from my perspective, the way I really see in the renewables tie-in is how are we actually integrating that and making sure it's tied back into more of the residential use, and how is that getting routed? And I think that's one of the things that is a big challenge about renewables, right? Is we can put in, especially in the East Coast, is we have ton of ability for solar, wind, and just getting that capacity on the grid and actually having the load in the balance of that is really a challenge. And yeah, it's definitely exciting times though. I mean, there's some fun problems to solve.
If I could be a little bit unorthodox and ask Amanda, since you're in a totally different region, how are you seeing?
It's fascinating because, I'm in Arizona, so, the Southwest, where sun is abundant while everyone is dealing with a lot of shoveling of snow. It was 80 degrees here yesterday. So my heart goes out to you if you're freezing, because we are not. But, the renewable kind of movement started early with us, and it's really normal to see every house on the street have solar panels, and, the schools have solar panels. And if you drive to California, it's all wind. So I would be curious. I actually haven't asked my local utility guys, what the shift has been, but I wouldn't think it'd be too much because we're already so highly renewable focused here. And it's just, the change has just been the load center, right? Like you mentioned, is the commercial slowing down, industrial slowing down, and all the resi is really picked up.
Yeah.
So with that, I'm going to go into Vanna White mode because we have our results. So 14% of you said it has somewhat decreased. 71% says it has not changed. 6% somewhat increased, and 9% significantly increased. Fascinating.
Okay. Great results. I'm so glad we asked those questions. So it's good to see what people are thinking about. So with all of that as preamble and just to set up Michael's discussion on disruptive technologies, he's going to tackle one for you and get into the nitty gritty about what light sensing technologies can do to help the grid. So thank you so much, Michael. It's been a pleasure working with you the last several years, and want to hear more. Thanks.
Yeah, thank you, and great job laying out, I think, the topology of the grid and where we're heading. And the one thing that we're fundamentally focused on is changing the way the world senses with light. And what we see is optical technology is a great technology to help actually solve some of these problems. And there's several differentials between just traditional PTs, CTs, resistive technologies that, with optical technology, we're a field sensing sensor. So what does that mean? Is that we all know electrical fields, magnetic fields actually come out of the power conductors, and we're actually measuring those. So we're not actually moving electrons. And by not actually moving electrons, there's several benefits to that. I think the first thing is safety. Safety is on the top of our minds, particularly around fire, around utility construction, across the board. And the optical technology really is fully isolated from the actual electron movement. So if you think about it, we have a sensor on the conductor, and it's optically connected to our data processor. So we're shooting photons through an optical cable into the sensor head, and it's coming back down. And so this makes us essentially 100% isolated from the system. Now, if a fault comes through, we're basically immune to it. So there's a huge safety component to it. The second thing is because we're a field effect measurement technology, is that we have a large bandwidth. So probably asking yourself, why does bandwidth matter? It's because we can measure harmonics. You think about traditional technologies, they act like a low pass filter, where with ours, we can measure up to 250th in voltage and up to the 11th in current. And we're actually expanding the technology to measure even further. And harmonics for both current and voltage is of big interest to our customers, particularly around the status of equipment, power quality, and it's actually a great indicator for condition monitoring. As we move the future grid and we start integrating more in its circular topology, this is going to become very important. The other thing that's exciting about it is that we're a fully digital system. By being a fully digital system, it gives us a lot of modularity, flexibility, accuracy, and precision. If you really look at our platform, optical platform enables a single solution that has multiple measurement types. And as we have more measurement requirements, as we're putting more data onto the grid, it's important to understand that we can't have 100 different solutions to do this. We need a modular platform that you have one M410, you have multiple sensors, they're all compatible. It's a plug and play system. So what we've really put together is a methodology, a technology that's forward facing and retroactive, so we can integrate to existing systems and actually really account for the future proofness coming ahead. But we do this all optically. So we're probably asking ourselves, how do you measure electric fields optically? So if you want to go to the next slide. We're going to talk about Michael Faraday. So in 1850s, this technology was actually discovered. So this is nothing new. What Makatu has done is we've commercialized this, and we really brought this to the grid so that we could bring this higher level of accuracy, isolation, safety to it. And so if you think about how Faraday works, it's really a pretty straightforward principle. And the fact is that you have a piece of glass that's basically reacts in a magnetic field. So we'll shoot a photon through this, and the way the photon comes back out changes. And that change is proportionate to the actual current, which is proportional to the magnetic field. One of the exciting things about Faraday measurement is that we have a huge dynamic range. So what do I mean by dynamic range is that we can measure from 10 amps up to 150,000 amps, and the sensor is essentially immune to it. We've done some really exciting testing, and this is some information I think Amanda can share with anyone who's interested about what we can measure and how we can actually measure the large dynamic range and still not to get saturated or actually have the sensor be damaged. Going on to slide 14, we measure voltage by something called Optical's effect. So Optical's effect, once again, was actually discovered in the late 1890s. And essentially, you can take a EO material shoot a photon through it. And as that photon actually goes through this material, you can kind of think about it this way, and this is the way I'd like to explain it, is that the actual atomic and stoichiometric geometry, is just a fancy word for the way it's made inside, actually starts to kind of go like this, right? So the photon's got to travel through this moving atomic structure, and it actually takes the light and slows it down and speeds it up. By using some polarization analyzation, essentially we're just setting it, we can actually get a nice sine wave that comes out that's proportional to the E field. This E field coming out is once again proportional to the potential of the line. So the exciting thing about this, if you think about it, is we're fully isolated from the system. So we shoot a photon through this piece of crystal, piece of lithium niobate, a field goes across it, that field actually changes the way the photon travels through it. We can detect that change and we can actually measure the electric field. The great thing about this too is that being a field sensor, I talked about this earlier, is the actual harmonics content. So we can actually measure much deeper harmonic content, which is very important for the grid of the future. And as we put more of this renewable in, is power quality, right? There's a lot of conversion from AC to DC. So
I'm glad you're describing what those formulas do, because I'm getting like painful flashbacks to engineering school. So thanks for the explanation.
Oh yeah, that's great. And it's a really exciting technology, and you know, we've been pioneering this, and I'm really proud to say is that we have the world's best engineers, world's best at what we do for voltage and current sensing optically. So, but this is really cool stuff we can do with this, Kristen, which is we can kind of talk about this in the next section here.
Let's keep geeking out.
Yeah, I love the geeking out part. So what we've done is we've taken these two different sensor types and made numerous sensing solutions. So we have a traditional line post sensor, and that traditional line post sensor looks a lot like a PBI or a Lindsay sensor, but however, it's fully optical. We also have line hanging sensors too. And the cool thing about our technology is that we essentially have one sensor for multiple voltage classes. So traditionally, you would have a sensor for 4 kV, 15, 25, whatever, going all the way up. But with the Makati solution, it's one solution for 4 kV to 35 kV. And also we have the same sensing technology can actually be put in different form factors besides line hanging, line posts. You can also do this underground. And we have solutions for all underground, for integration to switch gear, protection gear. We've had some really great partnerships and successes with that. Now we're moving up to the higher voltage classes, and it all uses the same technology. It all uses the M410. And what we're able to do now is, think about it, is that we built a technology that's easy to install, it's non-conductive, it's safe, has the highest harmonics measurement, highest accuracy, precision, and it's modular. And it keeps going, right, Kristen? Just keeps going, is that we can actually give you analog and digital data simultaneously. So let's think about that for a minute. We can actually give you a DMP point to talk to your ADMS system and control a local cap bank controller. That's just multiple uses of this, and it's the same platform. So what we're really trying to do is not have a complex system to solve this complex problem, right? We've simplified it down to the core of what we need to give our customers. So
the flexible sensing that you can do on any voltage and then translate that information, that sensing data, back to whatever type of system the utility needs to have.
Yeah, that's a great point, is that we want to be agnostic to who we report the data to. Right. There's a lot of great systems out there, and there's a lot of great control systems, and what we want to do is make those better. We don't want to have to replace those. We don't want to have to make those more complex. We're going to use what you have, and we're going to make it better. And here's another great example, is this is some of the first optical sensing and the first sensing in actual underground vaults. In underground vaults, and you think about the condition these are in, is that it's really dangerous in there. So we want to provide a solution, and it goes back to our whole idea is that we're electrically isolated from the measurement. If you look here in this right corner, this was a project that we're working with Con Edison, your neck of the woods, Kristen. Yep.
Where we recognize that blue helmet right there. Yeah.
Yeah, I'm sure you did. But you think, I'm really excited about this because we've offered an incredibly unique solution, completely retrofittable, and it's safe. So if you look here, we've actually able to take this technology and have it fit into a standard dead break 200 amp elbow. So by just using a T adapter, You can slap the sensor in, and this is what they did. They actually had this installed in about 3.5 hours, which is exciting where we can take this technology. Second thing too is that, you know, Makati, we have a bunch of expertise in the enclosure side of it, so that we can make sure that you have that fully submersion rated enclosure. So this system is completely set up to have, I think it's 7 days, like 14 feet of water submersion rating. So we're best in class in that also. So, and once again, it goes back to, we can put sensing where traditionally sensing was unavailable. So exciting right here. We just don't play on the distribution line, we also play in the substations. And the great thing about the substations is that we can enable lower cost build out and lower cost total cost of ownership. So if you look here, what we're able to do was deploy our technology for measuring on the build out of a substation and making that essentially by using a hanging sensor. And once again, is that the idea is that we don't want to have complex, expensive build out construction methodologies. When we switch to optical, we can really make that more streamlined. And the total cost of ownership also is really important. Just to touch on this, is that's the M410. The M410, you can kind of think about it this way, is you see how those, Kristen, those bays slip in? You can take one of our sensors, they all have the same shape in the end, just kind of put it in. It's a plug and play system. So any one of our sensors works with the M410, and we have that fourth bay.
So it's very modular?
Yes, it's very modular.
Okay.
The idea when we started architecting this is that we wanted to have something like take it from a telecom base, where if you remember, blade servers can just push in, pull out, same idea, but we do that with sensing. So gone are the days where you have to worry about complex offsets, commissioning. We do all that, and we can actually work with the customers or vendors or end users to commission the unit in the factory to get it how they want it. Exciting thing about the fourth bay though is that we've actually had a really successful partnership with Hubble, and you know, where I see this technology going is that fourth bay can now actually control different technology. And what they did this was to actually reclose their control, so they can take one of our sensors, plug this actual device into the fourth bay, wire it up, and now you can control a recloser.
Wow.
So
okay.
that's where we're heading to, modular.
Not just sensing, but now there's an action.
Exactly, that's where we want to go. We want to standardized system for sensing, but also putting in the abilities to now do action locally or on the edge or edge processing. That's where we're really heading. So let's talk about the data a little bit.
Preventing outages as well, right?
Exactly. Yep. Yeah. Exactly. Next slide. We'll start talking about the data a little bit. So, you know, I think our responsibility, Makati, we take this really serious. I think what we want to do is be able to give the real-time power quality. And, you know, we see that the world's dynamic, weather's changing, right? There's a lot of challenges that we have to take care of. And what we see as data being the new currency, and what do we mean by that? Is that if you can have preemptive understanding of the situation of the grid, of the equipment, it really gives you ability to take these outages and increase your ability to detect them, and so that you don't have one. So as we move forward, and as we're bridging this gap between renewables, between fossil fuels, is that we have an opportunity also to have a better understanding and what I call situational awareness. And this is going to be data driven, right? We need good data to make good decisions. And this will tie back to the ADMS, the OMS systems that previously would be reactive, non-reactive, but now we got to be reactive. We can't say, okay, something broke, let's go take care of it. Let's move the grid and migrate it towards where we can predict and we can make actually decisions before it happens. Likewise is that we see harmonics as the future. And we've had some really, really great partnerships with some of the leaders in renewables, and particularly down, Amanda, down your part of the woods, is that we see like people like APS, where harmonics are going to be a big component of their grid going forward.
You know, for people who don't understand the importance of harmonics, I think of it very simply, being the civil engineer that I am, not the mechanical engineer that you guys are, and electrical engineers. But do you remember that movie from like a long time ago, the Tacoma Narrows Bridge, where there was wind shear that hit the bridge and the bridge started going like this? You see that one guy running down the bridge trying to escape before the whole bridge collapses and go. Yeah. That's how I think of harmonics. Is this correct? When you're thinking about the resistance, what's happening to a system with the resonancy that's happening. Is that correct? Is that why this is so important to the grid?
Yeah, and thank you for such a great example. You really can think about it that way, is that, I think voltage harmonics are really helpful to actually help you identify in current harmonics the problems and the location. So
Okay.
what would generate harmonics is like nonlinear power supplies, highly inductive loads. A lot of the stuff you see outside of factories can really generate those harmonics. And what they do is they have the potential to really put strain on industrial components, industrial equipment. And so that's why power quality is so important, is that when you're actually, and where it's all coming from is a lot of it, if you think about renewable energies, they're DC, right? We have an AC grid, so we got to marry the two. And that conversion from DC to AC can really cause problems. You have an inverter or that's actually failing, that can put a lot of bad power quality on your grid. So something that we should be concerned about.
So it's basically trying to protect the equipment on either side, both the utility side and the customer side.
Exactly, and it's important to be that way too. I think that it's a good understanding. You think about the impact to data centers. You think about the impact to how much our life is actually on the internet. Data center power quality is really important. And they monitoring opportunities for that, not only at the substation level, but internally. So we really see this as a dynamic grid of microgrids, and in one wants to even small commercial grids that are connected to the larger utility grid.
Right. And the more that we have these different resources, the more you really need to manage what the power quality is.
Exactly. And you think about it too now is look at the, you can go on Tesla right now and order solar panels for your roof, and now your car is going to be the battery storage for it going forward. So that there's a lot of potential for an incredibly integrated grid, but we need information to control that. And software is going to be software driven, right? If you're going to be software driven, we all know it's as good as the data that comes in. So some of the questions we have to ask ourselves is, it's only good as the information they receive. So if we kind of pack that a little bit, is that if we get bad data in, we don't have enough data, or if data is not reliable, it really impacts our ability to be proactive or even reactive. So we got to ask ourselves is, what impact can we have by having better data? The second thing is real-time analysis on the grid. Is that, can we make decisions faster? Can we actually look at how we can take this data, process it, or even have edge processing? So there's a lot of opportunity for us as Makatu, for our solutions, but as the whole industry as a whole, to really push that edge processing in, real-time data, smart data, not necessarily more data. So I think that's really the way that we look at this problem. Yeah, so kind of talk about how do we do this? Well, the M410, it's actually a digital processing. So we actually can take all the analog signals. We take essentially the photon travels through the sensor, comes back, and then we convert that to digital. And by being a digital system, we're really excited. The fact is that we have 15,000 samples per wave cycle. So that gives us the ability to measure way beyond the 250th harmonic. But in all practicality, the signals get lower and lower. So 250th, is really where we brought this technology and the potential to bring it further. I think granularity is really important, is to have it configurable. Some data means some application for each end user. So it goes back to the whole idea is that data overload can also be a problem. Let's give the data that means the most to the end user. The other exciting thing is that the M410, the M410B is pushing towards what we call edge analytics. Let's make wise decisions on the edge, because we all know bandwidth, communication, that brings a whole new level of infrastructure and challenges. So if we can make wise decisions on the edge and have a learning system that can actually say, yeah, this makes sense, this makes sense, I think that's a big push of the platform that we can provide. I can't push this enough too, is that modularity and flexibility. The M410 really enables these applications by having the DMP output that can communicate essentially any ADMS system, but also locally control using LEA outputs. And LEA is just the low energy analogs. It's exciting. We're really excited too. We're coming out with a new product that gives you 120 volt output. So you can actually go retrofit even further back to equipment. Our goal is to give you sensing, not to have to change your whole infrastructure to go do it. So, and I think, you know, finally, new applications can come in like Flizzr, fire prevention, VVO, a lot of stuff we can really start to push into further, and you know, do this in a cost-effective, low ownership methodology. So our goal is to give you the M410 with the ability to use multiple sensors for all the different sensing applications that you may need. So we're really pushing towards that. So with that said, I'm going to let's do another poll. Kristen, you excited for this one? Because I know I am.
I'm excited for this one.
Awesome. So let's see. How happy are you with the quality of the harmonics data reported by your grid measurement systems? So are you dissatisfied, somewhat dissatisfied, neutral, somewhat satisfied, or you're totally satisfied? So Amanda, what's your thoughts about this?
I'm curious. I am a double E geek here who is very interested in it. And in my experience, it really wasn't something that came into play as an operational engineer until it was really a problem, right? Until a big manufacturing facility with highly sensitive equipment called because things were breaking. And then we'd reactively deploy power quality sensors. It was never kind of that proactive measurement. So I'm curious to see what people say.
Yeah, and my question is that I think to follow on to that, if a technology can enable both, do you see that as a value for, and maybe Kristen, for you and being outside of the Makati organization? What's your thoughts about that?
Yeah, so I think what's happening when you I'll take a large step out, when you're saying that you want to have more distributed resources or other types of resources that are renewables, even if they're a remote plant, on the grid, that the importance of the power quality that is propagating across near and then propagating across the grid, you want to make sure that you are establishing an understanding of what that means and what to do about it if it's getting out of hand, quite frankly. So I feel more comfortable knowing that as we're incorporating more and more renewables or other types of resources on the grid infrastructure, that our grid itself has the ability to correctly identify what types of electrons are flowing back and forth so that we understand how better to manage that grid. Because like I said before, my rudimentary electrical engineering understanding of the grid, even having worked at utilities before, is basically it was unidirectional. Backfeed was bad. Now we've got all this multiple. So now we're redefining how we generate and where we generate our electricity, and that really impacts how the grid needs to be flexible and robust enough to address those needs and still maintain the reliability.
Yeah, and it's, go ahead, Michael.
Oh, no, Amanda, no, go ahead, I'm sorry.
We got results coming in, and I will say my favorite line that we've been using lately when I've been talking to utilities or different partners around harmonics is, we don't know what we don't know, right? Yeah. And it's a little terrifying when you do find out, right? So really interesting. Yeah. So the results are in. Okay, so we've got 18% at dissatisfied, 21% at somewhat dissatisfied, the bulk of response 55% at neutral, and 6% at satisfied. So we have some work to do to bring this data to the people, it seems like.
Yeah, and man, I know what's the exciting thing is Makati's leading that charge in harmonics. We really are best in class, and we really can provide that information. So as this becomes more and more as part of the decision process in the new currency, I couldn't be more excited. So
yeah, we're a bunch of harmonics geeks these days, that's for sure.
The rest of us are catching up, so we're happy about that. Yeah.
Yeah. Excellent. So some case studies here, and I just kind of go on to this next slide. Kristen, I think just kind of talking about both of us, I'd like to get your opinion, kind of keep this a little bit more open, is that where is the use cases for sensing? And my perspective, and I love to hear yours as we kind of go through this, but as far as solar farms go, it's an exciting challenge. And solar farms is, at least in upstate and East Coast, is that we have an incredible deployment. We're making great progress with it. Is how do we tie the energy transfer in? How do we actually get that power to where it needs to go? And I think sensing can really help that dynamic balancing and load transfer of not having to build as much infrastructure as the possibility, right? Kristen, what's your thoughts on that?
So I think that if this can be an information system that is much lower cost than building out other types of infrastructure to try to mitigate or measure, I'm really a proponent. So when you're talking about these different use cases, you're going to have to, like, we're talking to Amanda who's in Arizona, and you're upstate New York. I'm here in New Jersey watching the snowfall yet again. All different types of regions in the US and the world, of course, that have different types of resources, grid needs, user operations. And so I think the use cases for sensing, it can is way more than just the 5 that are on this categorized on this page. But the point is, how best can we sensor to gain information to make actionable decisions about it without overbuilding or over investing? So if this is a much lower cost option to find out the information at much deeper levels, then that's something that I think we need to investigate, and how these use cases can enable that kind of information.
Exactly. And the thing that we could get caught up in is that you can have information overload. We need quality information, and we need information that has insightful, right? We have to be able to have insightful information. So, you know, I think that's where having higher accuracy, higher precision is great. And also the ability to actually do something and think about the information before you send it up the tree. It's exciting. And, you know,
I used to say when I was at the city of New York managing the energy infrastructure there, which was a big challenge, that we had a lot of data, but not a lot of answers. So we needed to figure out what this data actually meant. So I think if that's what you're getting at and getting to, what's the smart information, the informative, actionable, without being overwhelmed.
Exactly. And I think the last thing on the use cases is that it's different for every location, and we see different use cases in Europe. We see it North America, South America. So a lot of exciting things, but where we can help in particularly is that it goes back to our flexibility, and we have some exciting technology too. If you look over on the picture on the left here, is we actually are installing the first groundless voltage sensing. So groundless is, if you always think about traditional PTs and CTs, if you don't have a ground on one of those, that could cause issues. But if you got to remember, we're a field effect sensor, so we're actually able to reference the actual case around these unit substations. And as you know, Con Ed has a ton of these. So we were able to put high quality, high reliability, low cost of installation solution into technology. It's been like out there, was it 60, 70 years? How old are those things? So
I don't want to know.
Yeah. So what it really it's doing is that it goes back to is that by having a flexible modular sensing solution, it enables to have that equipment to not have to go through and tear it apart to put this in. For this particular installation, it went in about a day. Likewise is if you look at the center and we go to vaults, if we go into additional controls, you look at the picture to the right, we're actually installing sensing on existing new construction too. And this is a rather large transformer in New York City also, is that you need flexibility, but we don't need a million solutions to do that. That's where the M410 comes in, and the flexibility of the sensing solutions we have. So, all right. So this is the fun part, Kristen.
Yeah, okay, we're ready. And I will say we've gotten some great questions coming in, and I've already asked the moderators on the side behind the scenes, thank you to Clarion Events, that if anything we don't get to, if you submitted a question, you will not be forgotten. We will make sure we get back to you when this is all wrapped up with answers via email or phone call. So with that, let's just jump in, guys. So a couple just technical, not like optical technical, but technical presentation technical that I can handle real quick. Will the slides be distributed to participants? Yes, you will be able to get these after the presentation, both the slide deck and the presentation. Just make sure if you don't see it, reach out and we will get that to you. So this one is interesting, given the world climate. Emma or Michael, I will hand this over to you. How about hacking by foreign adversaries?
Yeah, no, what's the exciting thing about that is that, what we say network security in protocols is that what differentiates us from other technologies, particularly bird on the wire, is that we're fully integrated with the utilities network. So we have the ability to use their wire drop, or if they have a wireless radio that's an encrypted system, we communicate directly on that. So I'm really really excited about the differential that gives us, because now you think about it, is that the level of security of the utility is our level, and we don't have wireless communications, we don't have bird on the wire, we don't have any wireless transmissions at all. So it's a really important thing, and I think as the grid of the future moves forward, network protocols, network security is one of the top things we need to focus on. We can't have people shutting stuff down with bad intentions.
Amen to that.
Yeah.
Here's a just simple technical question. Does the underground sensor use IEEE 386 interfaces, which is the standard for load break and dead break, I believe, connections, which I think is yes, because we go into anyone's elbows, right?
Yeah, so we actually, for practicality, if I remember that standard correctly, that's we're using the 200 amp dead break elbow, and we designed that to fit in multiple vendor types. So if you're using Elastomold, Eaton, whatever the brand is, we fit 90% of those. So essentially, if you think about the way that looks, it looks just like a cable terminal with a cable terminal that just slips in, and now you have a sensor. So, and if you want to go from 600 amp to 200 amp, you can just use an adapter, 600 to 200 adapter. So then you just push it in. It's really cool stuff.
Yeah, again, going back to that modular, right, and how we make it easy to go on older equipment, no rip and replace. So here's a statement that someone made that I want to throw out as a discussion point for both of you, because I think it's interesting, is Harmonics can and will burn surge suppressors and create issues on data centers and office equipment. And we've been talking a lot about data centers internally, and I'd love to get both of your thoughts about, how important it is to protect those kinds of assets at this point.
Kirsten, you want to go first?
From the customer side, I'll speak from the customer side, even though I don't represent any customers that have large, actually I do represent some customers that have large data centers. They are very protective of course, their assets, and the way the power quality and reliability of power to those data centers is of utmost importance. So, to the first question that was asked, like instead of a foreign adversary actually being able to hack, you certainly don't want to be able to cut off power to all your data either. So as you're thinking about, I'm sure, Mo, as you're looking at harmonics as an impact to data centers, how do you approach that as a use case?
Well, I think it goes down to this, is that Amanda's laid out a great theme on this, is that we don't know what we don't know. So what we need to do is put monitoring there, and it needs to not stop at the data center substation that they own. It needs to go inside of the building also. There's a lot of opportunities there, and as you can see, is that some bad weather can cause some really big issues, and I think understanding is the first step to it, and I think that's a lot of technologies out there to prevent it, but we need to measure it first. You need to have situational awareness. So yeah.
And do you think that the approach that you, not knowing what you don't know, when you approach with an installation, starting with a few key identified places to actually, or locations for sensing, monitor, establish what you do know or have learned from that, and then maybe progress to another stage of additional sensing where needed once you found out information, so it's not you're blanketing this thing with more and more sensors, which may not be necessary?
Yeah, I think that the logical approach and the way that we're really seeing this lay out, because you gotta remember, this is groundbreaking. We're moving into areas before where some of this level of technology wasn't available, but even deployment is that you can really think about it as the power breaks down from the substation into the actual separate panels and powering banks. There's a lot of opportunity there to really see what's going on, because you could have terrible harmonics right now and just not know. It really goes down to what you're monitoring. And some other exciting projects we've been working on is microgrids for universities, and the same idea is happening here, is that we're monitoring now on the substation, but now we're monitoring on the built-in feeds from the 4 kV transformer down to 480. So we're getting into that side also. And there's a ton of technology that goes from the 4 kV back. But one of the things we're providing is that fidelity and that depth of harmonics that you can really get. So yeah, it's concerning, but also I think there's a lot of opportunities.
Could not agree more. And so here's an easy one on the harmonics theme is, can I get harmonics directly from your product?
Yes.
The easy one. Okay, here's a more fun one for you, MO. And we all lovingly call Michael Oshetsky MO because we have another co-founder named Michael Sexton, so we have a lot of Michaels around here and it gets a little confusing. So if your name's Michael, you're welcome to come work for us as well. So MO, this one is, I'm very interested to hear the answer for this one. So it says, I was wondering where exactly artificial intelligence and machine learning algorithms are being used in the data, and what is the aim of it? Of what you can share.
Oh yeah, what we can share. So if you really look at the data, there's a lot of information in there, and I say that in a very coy way, right? Is that if you can apply learning algorithms to this, and this is really what our technology has the ability to do, is that you can actually start to see the cyclic patterns. What's outside of this? What's part of a normal day? What's part not of a normal day? And as we advance this technology, and this is something that Makati is really looking forward to get even more in the future, is the ability to say what's out of normal and what is within normal. And that's where AI will really play. And as our ability to do more advanced condition monitoring increases, is now we can start to look at the harmonics and say, okay, this is changing from state A to state B. Have we seen these situations before? And if so, how did this tie back to the failure? So AI and edge analytics is really going to be an exciting point of this, is that, okay, it's like you said, Kristen, I can give you a ton of data, but what does it all mean? Or I can say, hey, your transformer is going to blow up in 30 days. What does that mean to you, right?
Super exciting stuff.
$2 million at the minimum.
Yeah, oh my goodness. No, that's fantastic. And I think it's only going to get more exciting, right, as we move forward into the future. Okay, so here's another easy technical one. The power output of your M410, is it 100 to 240 volts AC or just 120 volts AC?
Actually, if you're talking about the low energy analog outputs, it's 0 to 10, and we actually have a module we're excited to launch. It's within the end of this quarter, I believe. We're looking to get that out. Is actually we can take that and put that out to 120 base, just like a standard PT or CT. So
fantastic. And have customers installed disconnects for the Makati sensor ground?
I don't really think I've seen that. It's a great question. I haven't seen it, but that's something that, Amanda, we can definitely take and get that back. But I haven't really seen that in a lot of the applications, and particularly in the line hanging, it's common for the ground connection to be non-disconnected. So
perfect. And let's see, what is the maximum power supported? Can I hook up a modem to it?
Maximum power supported. So the way the system works now is 12 to 24 volts you power the M410 with. We don't self-power. So maybe that was the part of the question. I'm just trying to dig into a little bit. But yes, we can support a modem. We have a standard RJ45 telnet protocol. You can communicate in multiple ways. You can actually have multiple ports open simultaneously. So you can have a DMP port. You can actually communicate with the unit separately, simultaneously. So we got a lot of flexibility there. But yeah, if you have a modem, most likely we can communicate with it.
Okay, we're going to take a couple more before we wrap this up. We've got about 6 minutes left, and there's tons more coming in. So thank you, everyone. This participation is fantastic.
Yeah.
So here's another good one, and I'm excited for your answer because it's not what people are going to think. Are these metering class sensors or relay class or both? Any integration with major switchgear manufacturer OEMs yet?
Multiple questions there, so let's break them down. So as far as we are pushing for our metering class, that's a big push for this year. I think that will fundamentally change the way that these sensors can be deployed. So that's an active project we're pushing through. Some really exciting progress on that. And actually, we're excited that we're going to EPRI to verify some even performance upgrades we've done. So, you know, as far as the technology goes, and you can see that we are dedicated to be better and be better every day at measurement. So you're going to see more and more exciting releases both on product lines, performance, and the great thing about it, it's all software. So software upgrades can give you better performance. And I think that's going to be an exciting thing, is that we can't get in the mindset that every time we need new hardware, right? And you can start to see that with cars, right? You look at your Tesla, and I love this example, is like a new package is coming out and Elon does a tweet, right? Now this thing can park itself in my garage. That's what we want. And I think that's what we need as the grid goes forward. So.
Yeah, and I think on that one in particular, for anyone listening that is wondering where this came from. So normally when you have instrument transformers, you'll have two different sets, one for metering and one for relays. And our goal is to actually combine that into one unit of measurement, which is powerful both, you know, from a total cost of ownership, from a real estate perspective. We all know substation real estate is extremely valuable these days. So it's very exciting to be able to combine that as a technology solution. And I think with the OEMs, you know, it's an absolute yes. We're doing some really incredible things with partners, and I mean, share what you want about kind of what we're doing and what we're allowed to share.
Yeah, you know, we have an awesome partnership with Eaton, really exciting partnership with Hubble, and you know, we've done some joint projects that's included like Eaton, Siemens, Hubble, and it's just like, it's exciting to see the level of demand from our customers to work with, you know, these major suppliers that put our technology in. That to me was a real point of transformation for me to think about where the technology could go now, is that you might be buying our products by buying someone else's products, which is exciting. And as we go forward, I think people want reliability, I think they want the safety, and I think they want the, you know, quality of data. So
yeah, and I think, Kristen, I'd love to hear your thoughts on this too, is something that I know I'm really passionate about, Michael's passionate about, is not just getting the sensors out there, right? Is really delivering the solution that makes a difference in the industry, you know, no matter how that looks or who we're working with. And, you know, what is your perspective on, you know, different companies partnering? It's that, you know, the co-opetition, right? It's cooperating with your competition to make things, you know, to really do things the right way.
Yeah, well, to be just practical about it, a lot of utilities already have their established partnerships. So they have the people that are the companies, or the equipment, the procurement processes, that they're familiar with who those companies are. And that's a part of what that procurement process is for a big utility or a big manufacturer industrial company. So if Mikatu is partnering with these big companies in order to improve their products, their services, and that can then help the utilities understand the benefits of this augmented product solution set that can be provided to them through a partnership that they have some familiarity with, I think that's a great thing. I also think that there's nobody that's going to solve these problems by themselves. So we're kidding ourselves if we think that it's just one person or one entity that can do this all. So having the flexibility and the cooperation to be able to collaborate with others in partnerships is going to be very beneficial. But being strategic about how you do that is key.
Yes. And I will just open the invitation. I spend at least a quarter of my week on the phone with different partnership opportunities of utilities like, hey, can you go talk to this relay vendor? Hey, can you go talk to this switch vendor? I want to put things together. So we are so open to those conversations. We love thinking about how we can make things better. So if you are another vendor, if you are a utility thinking about how could I make this work with this piece of equipment, please shoot us an email, reach out on LinkedIn, however you want to get a hold of us, because we would love to help in any way we can. So with that, we have 1 minute left. So I know we have a ton more questions. We will answer them to you. We'll get them out via email something to make sure we get all those answered. But with that, I will close it out with handing it over to Rod to close out the presentation. And from the Mikatu side, I just want to say thank you. This was a great conversation.
Yeah, thanks, Kristen. Yeah.
Thanks to you all. Great talking with you.
Yep.
Great job, Amanda. A fascinating discussion you guys had on the potentials and experiences out there, deep snapshots of the grid picture, and a good handle on where it's going and best ways to measure and deal with those changes. And I thought our attendees' responses and your poll questions were really interesting. A lot of uncertainty out there, a lot of excitement though about where things are going. And for our audience, I want you to remember that Makatu and our presenters will get to your questions if they weren't able to during the event. So we've come to the end of our webcast today, and I want to thank our moderator and expert speakers, Amanda Freit, Vice President, North American Sales for Makatu, Michael Oshetsky, President and CEO of Makatu, otherwise known as MO in-house, and Kristen Barbado, who is founder and CEO of Build Edison. Thank you so much for your expertise and insights on this webcast. A Grid Disrupted, How Optical Sensing Manages the Chaos with More Accurate Digital Measurements, sponsored by Makatu, Measuring the Future. Now, this presentation will be available on demand within 24 hours of this live event, and I believe the presentation slides will be available also if you request them. On behalf of Clarion Events, Power Engineering, and Power Grid International, and our sponsor, Makatu, I want to thank you, our audience, for attending. I know you're very busy, and we appreciate you taking this time and hope you've gained a lot from it. I look forward to sharing future webcasts with you. Until then, stay safe and good luck with your work in this wonderful industry. I'm Rod Walton. Have a great day, everyone.